Imagine a world bathed in the warm embrace of a distant sun, a world where days and nights stretch out for 4 times longer than our own. This is Tickel, a Mars-sized moon locked in a celestial dance with a colossal gas giant. This giant, a swirling behemoth resembling Jupiter, holds Tickel captive in its gravitational grasp. Tickel's journey around its parent star is a sight to behold. The gas giant's immense gravity tugs at the moon, forcing it into a synchronous rotation. This means that one side of Tickel always faces the star, basking in eternal daylight. The other side remains shrouded in perpetual darkness. Between these two extremes lies a narrow band, a twilight zone where the sun barely peeks over the horizon. This zone, a ribbon of perpetual dusk and dawn, is where life on Tickel truly flourishes. But Tickel's story is not just one of a moon locked in a gravitational embrace. It's a story of resilience, of life adapting to extraordinary circumstances, a story written over billions of years. For most of its existence, Tickel basked in the gentle light of a G-class star, a star much like our own sun. Life arose in these balmy conditions, evolving slowly and steadily over billions of years. The first chapters of life on Tickel were written in the planet's vast oceans, single-celled organisms painting the canvas of life. But the universe is a dynamic place, and even the stars themselves change over time. About 1.5 million years ago, Tickel's comfortable existence was shaken. Its parent star began to change, transforming into a much hotter, more intense O-class star. This new star bathed Tickel in harsh ultraviolet radiation, threatening to extinguish the life that had flourished for eons, yet life persevered. Tickel's thick atmosphere, a product of its active geology, acted as a shield, absorbing the worst of the radiation. A strong magnetic field generated deep within the moon's core deflected the charged particles spewed out by the star. And as if these defenses weren't enough, the gas giant itself provided a protective embrace, its own powerful magnetosphere extending out to envelop its orbiting companion. Life on Tickel, shielded from the worst of the star's fury, adapted to its new reality. Evolution, the master tinkerer, took these challenges and crafted something extraordinary. The increase in ultraviolet radiation from the O-class star presented a unique challenge to life on Tickel. But life, as it so often does, found a way to turn a challenge into an opportunity. Plants and animals evolved specialized cells capable of absorbing UV radiation and re-emitting it as visible light. This process, known as bioluminescence, transformed Tickel into a world of ethereal beauty. The twilight zones, bathed in the dim light of the distant star, shimmered with an otherworldly glow. Forests lit themselves from within, a tapestry of glowing plants and fungi painting the landscape in vibrant hues. Even the animals adapted. Some creatures developed bioluminescent skin patterns, using them for camouflage or to attract mates. Others evolved specialized organs capable, illuminating the darkness and stunning their prey. Bioluminescence became more than just a survival mechanism on Tickel. It became an art form, a language, a testament to the boundless creativity of evolution. On Tickel, life has evolved Zeno-DNA, XNA, similar to Earth's DNA, allowing life to create the blueprints for magnificent organisms. XNA has a triple helix structure and 3 strands that twist for the triple helix structure, forming a triangular prism or a more compact spiral. This structure increases stability under high UV radiation and extreme conditions, as 3 strands offer more bonding sites and redundancy. Instead of just hydrogen bonds, XNA uses a mix of hydrogen bonds, silicon-oxygen bridges and van der Waals forces, reflecting the moon's carbon-silicon hybrid chemistry. A truly alien concept. A triple helix structure with 6 novel nucleotides forms a more complex pairing system. With vastly larger sets of amino acids and novel molecular building blocks, a richer genetic vocabulary takes shape. Animals, plants, and fungi have a unique opportunity to evolve some very alien traits while still following the rules of chemistry and biology. Life in Tickel has evolved under the extreme conditions of an O-class star, a delicate web of relationships woven over billions of years. It is a symbol of the moon's resilience, its ability to transform adversity into an opportunity for life to thrive.
All life, as we know it, are carbon-based life forms. They have DNA or molecules that carry genetic instructions for the development, functioning, growth, and reproduction of all the organisms and many of the viruses that we know. It's a double-stranded helix formed by base pairs of nucleotides attached to a sugar phosphate backbone. On Earth, we're able to isolate certain genetics mutations and exploit those in our agriculture sector and food production and some of the animal selections that we choose to keep and domesticate. On our theoretical moon Tickel, life has some unique challenges to help drive its evolution. It has an O-class star that emits high radiation. It's tidally locked to a gas giant that also has some forms of radiation. It's on a small Mars-sized moon, and in the twilight zone there are going to be some high volcanic eruptions and seismic activity. So the evolution of a triple helix XNA with 6 nucleotides and carbon silicon chemistry isn't random. It's a response to an extreme environmental pressures and the available resources that it has.
Life on Tickel has evolved in a very unique way dictated by extreme environmental conditions and the availability of resources. This gas giant, cloaked in swirling bands of colorful clouds, imposes some challenges of its own. It tidally locks Tickel, creating 2 extremely different environments in an alien world tugged in between fire and ice. This moon is shaped by these colossal forces and extreme weather patterns. Tidal forces cause volcanic outgassing, delivers helium, sulfur, sulfur dioxide, hydrogen, and oxygen like that of Earth, only in more abundance. The magnificent rings, composed of countless icy particles, range in size from tiny grains to massive boulders, deliver water and other gases and minerals to the moon from orbital debris. The moon's surface is a tapestry of craters, volcanoes, and vast plains. This Mars-sized world likely has a differentiated core with thorium concentrated by tidal heating and a silicon-rich crust. It's a world of stark beauty, a testament to the universe's boundless capacity for wonder.
This planetary system orbits a O-class star on a 13-year eccentric orbit, making each season 3.25 Earth years long. The winter season, known as perihelion, brings stronger storms and colder weather like on Earth. Our moon Tickel and gas giant Odin are at its closest point to their sun and solar radiation peaks. Followed by spring, the storms are less frequent and humidity is boosted by volcanic activity. The summer, called aphelion, is calm with minimal solar flares and drier air. The fall exhibits an increase of winds with some frost events that intensify as UV radiation and solar flares increase. The seasonal changes are the driving factor of some of the weather patterns and temperature differences. Biology is directly affected by weather, temperature, and other environmental conditions, and this drives evolution. This unique combination of chemistry and astrophysics creates some unique and truly alien concepts for biology on Tickel.
Life on this moon has adapted to the rules of physics and chemical resources available. The constant gravitational tug-of-war between the gas giant and its moon generates immense tidal forces. These tidal forces, like a cosmic sculptor, shape the moon's internal structure and drive its geological activity. Volcanoes erupt across the surface, spewing molten rock and gases into the thin atmosphere, a testament to the moon's fiery heart. These eruptions release a cocktail of chemicals and nutrients into the environment, providing the building blocks for life. The cycle of volcanic activity, driven by the dance of gravity, ensures a constant supply of these vital ingredients. A silicon-rich crust offers the opportunity for organisms to incorporate it into their biology. Plate tectonics deliver these rich thorium and silicon deposits from the poles to the temperate and equatorial regions of the moon. These organisms have adapted and evolved to process the decaying thorium, harnessing the helium and incorporating it into their biology.
Solar winds from the O-class star deliver helium nuclei to the atmosphere. The gas giant's atmosphere also contributes trace helium through the process of outgassing and impacts. Volcanic activity, driven by tidal heating, releases helium from the mantle. Helium accumulates in the thick atmosphere, retained despite the low gravity. UV radiation forms a sodium-oxygen matrix that traps the atmospheric helium. This matrix cools and condenses into helium frost in the twilight zones, especially during the winter with higher solar activity. Winds and weather driven by storms deposit helium frost onto fungi, trees, and soil surfaces. The organisms have evolved specialized cells that incorporate the helium into the physiology to gain mobility in this alien world. Excess helium escapes back into the atmosphere and repeats the helium cycle like the water cycle on Earth. Tickel truly has evolved in the most hospitable environment and conditions. Next time we will look at some of the organisms that call this alien world home.
On our theoretical moon, life has evolved much like life has on Earth, except it has different circumstances and environmental conditions. A 13-year cycle around the sun brings about some interesting weather like the helium frost, and there are volcanic activity at play and tectonic plates stronger than that would be on Earth. So this excess amount of helium in the atmosphere creates an interesting adaptation for animals to evolve and incorporate helium into their biology. A helium cycle, much like the water cycle and the nitrogen cycle and photosynthesis on Earth, where helium is used in their evolutionary timeline. When developing the concepts for the moon Tickel, we had to look at a number of different factors, including volcanism, plate tectonics. We had to look at the orbit of the moon and its relationship to the planet that it orbited and the tidal forces the planet would put onto the moon. We had to look at the type of star that the planet was going around, the distance from the sun that the organisms would be. We had to look at the weather patterns and what type of weather patterns that this kind of environment would create. And helium frost was one of the unique ideas that we come to, and we had to figure out how that the organisms would interact with all of these different factors and how that would play into their evolution.